Hello and welcome to Lecture 7 of Introduction to Computational Literary Analysis. Today we're going to talk more about tokens, tokenizing words, stems, lemmas, and that sort of thing. All right, here we go. So here we are again. I'm going to open up a new Jupyter Lab notebook in Python 3. I'm going to give it a name. Tokens, stems, etc. And I'm going to annotate this in Markdown. Yeah, and so we didn't get to talk about what stems are the last time, or lemmas, but these are other ways of collapsing words into their categories, right? So in the discussion that we're having right now on Zulip, one of the things that came up is different forms of the word mystery, right? So you have words like mysterious, mystery, and mysteriously. So how do we deal with the desire to sort of count these as one word type, and disregard the ending? So some of you may have already figured out that if you just do a search, if you just search the text for the beginning of this word, mystere, right? Because that is in all of these versions, that sort of allows you to collapse all three of these versions of this word into just one. So, so this is what's known as a stem. Okay, so a lemma is similar to that, but a lemma is sort of like the dictionary definition of a form. So let's say that we have words like went and go and goes. So because here you have a different verb form, what you want to do is collapse all of these to just one verb, to go, right? So you can imagine this as like looking something up in the dictionary. You're not always going to be able to find something like running, but you will be able to find something like run in the dictionary. You might also not find something like runs. So what you want to do is collapse all of those into something called lemma, right? So in this case, go would be the lemma. And in this case, run would be the lemma. So let's see how that works. The NLTK has stemmers and it has lemmatizers. So it has functions that can turn a word into these forms. And that can be really handy. However, they don't always work as expected, and like everything in natural language processing, there are like 5 or 6 of them, and so knowing which one to use and which ones work the most effectively is kind of half of the problem. All right, so again, we're going to want to import the NLTK, and this should just work. And within NLTK, there is a module called stem. And so stem contains a number of other modules. You can see it contains about 5 or 6 different stemmers, and it contains a lemmatizer. Yeah, so why don't we get a few of these? So one is a Lancaster stemmer. And we can grab it using this incantation here. And now if we were to investigate this, yeah, if we were to look at what it is that we're dealing with, and I'm going to bring up the contextual help here. So what we've done is we've taken this class, this Lancaster-Stemmer object, and we've assigned it to this variable called Lancaster-Stemmer with a lowercase l. Now, if we look at the documentation for this, it says that we do what we just did. In other words, we have to assign it to a variable first. And then once we've done that, we can run .stem on it. .stem is a method of this stemmer object. And then we can provide a word, and then you see it returns a stem for that word. Okay, so Lancaster-Stemmer .stem will stem a word using the Lancaster-Stemmer, it says. Okay, so let's try with mysteriously. Yeah, maybe we want to do it like this. Okay, yeah, so here it is. Yeah, we forgot to add the parentheses there. I forgot to add the parentheses at the end. So this fully instantiates this object. Now we have this object, Lancaster-Stemmer, and now we can try it again with the word mysteriously. So yeah, you can see it stems mysteriously to mystery. Yeah, let's try this a few more times. I'm just going to copy and paste this. Mysterious, it collapses to mystery. Yeah, what if we were to try just mystery itself? What's it going to do in that case? Mystery. Okay, great. So what this does is it takes any kind of mysteriosity, any kind of word that that seems a little mystery-like, and it collapses it to this word mystery. So you can already imagine how this kind of thing could be useful for text analysis, because if we're interested in tracking words like mystery, we want to be able to collapse all of these forms into just one. Okay, so you may have noticed I've just copied and pasted a few things here, but of course, to make this more Pythonic, it might be better if we had written this as a for loop. So we could have said for word in, and then we provide a list here. Mysteriously, mysterious, mystery, Lancaster-Stemmer, stem, word. Okay, so this does the same thing. But you see, it doesn't output anything. And that's probably because we're not printing anything out. Yeah, there we go. Mystery, mystery, mystery. And if we had wanted to, another thing that we could have done here is we could have just assigned these to a new variable. So I could call it like new mysteries, and I could make it an empty list. And then here, instead of printing them out, I can take this and I can append it to my new list. So new mysteries dot append the stem. Actually, I'm going to make this a little bit easier to read. By assigning to some variable, because this is a little bit hard to read. So what this does is it's going to go through each word in this list, and it's going to stem it, and then it's going to add the stem to this thing called new mysteries. Now if we look at new mysteries, yeah, it should have 3 stems from these 3 words. Yep, so that's pretty cool. Let's try out a few different stemmers and tokenizers. So what else do we have? and again here I'm just pressing dot and I'm pressing tab, and that allows me to sort of look through a whole lot of other stimmers here. Porter stimmer, if you look down here, it will tell us even the original paper in which this was published. This is, as you can see, kind of like an old stimmer from 1980, but still works and still in use quite a lot. Porter stimmer tends to chop off words very aggressively. So, why don't we try the same thing but with the Porter stimmer? Get the Porter stimmer object. And now we can run it on something like mysteriously. I might have the wrong syntax here. Oh yeah, so it's .stem, I believe. Yeah, so you can see here it's chopping up the word very aggressively. And chances are this probably will not work the same with just mystery. Actually, it does. That's kind of amazing. So probably what it does is transform the Y to an I in all cases before chopping off the ends of things. So let's say that I wanted to do the same sort of thing using the Porter stimmer. Yeah, I could copy and paste this whole thing. At the same time, there's this thing in computer science called the dry principle, and you might be familiar with this. The dry principle, it says, don't repeat yourself. And basically, that just means that instead of copying and pasting code, it's usually better to write some kind of reusable function. And for this, I'd need to introduce functions, which I should do pretty quickly. Because this is going to be a short one. But yeah, here we go. So a function, it looks like this. It starts with def, has the function name. After that, then it has any parameters it takes as input in parentheses. Then it has the body of the function indented 4 spaces. Then it has a return statement which gives the output. Okay, so let's look at an example. So let's say that if I want to Lancaster stem or Porter stem any word at all, this would be a good function because it's something that is repeatable. So looking at what I'm doing up here, I'm going to say, okay, first define a function, and I'm going to call it Lancaster stem, let's say, and this takes a word as its input, and then you see I pressed enter and it's automatically indented the 4 spaces for us. And now what I can say is I'm going to make this into the stem for that word, and then I'm going to return the output, which in this case is that stem. So now I can change this. Actually, I'm going to keep this list of mysteries. Remove everything else. Now, when I run this, it doesn't do anything because it's just registered this function. It's just remembered it. But if I were to write Lancaster stem it, now I could use this just as any other function. I would give it a word like mysteriously. It gives us mystery. I could give it a word like mysterious, and it gives us mystery. So I've basically taken all of that logic and I've abstracted it away, and I've made it a whole lot simpler by writing this function that does it. Yeah, if I wanted to, I could add more parameters to this to allow you to vary the method that you use to stem it. Anyway, we'll talk a little bit more about functions as we go along. But yeah, before I finish this, I just want to show you one last thing, which is lemmatizing. Okay, so in the NLTK, in stem, there's a WordNet lemmatizer all the way at the bottom. And if I instantiate this to a variable called lemmatizer, the function is lemmatize, it looks like. And if I give it something like mysteriously, is this going to work? It might need some data to be downloaded. Okay, so if this doesn't work for you, chances are it's because this uses WordNet, and WordNet requires you to download a certain amount of data to your data directory, and so you might have to run, NLTK download and give it book if that doesn't work for some reason. So, yeah, lemmatizer. What will happen if we say went? So it doesn't collapse it to the dictionary form in that case. What about running? What about runs? So it collapses runs to run. What about lightest? What about heaviest? So most forms it doesn't change at all, it looks like. So in other words, it's not a very good lemmatizer. It can change some forms to their dictionary forms, but not all of them. So this is something to keep in mind. I might recommend using the Lancaster stemmer before anything else, but you do have to keep in mind that in some cases with some of these stemmers, you end up with word forms that are not strictly word forms. They are stems. They're kind of chopped off at the end. So really the best way to familiarize yourself with how all of this works is just to play around with it, right? So while you're running through all of this at home, put in some of your own words, and see if you get anything unusual, see if you get anything surprising. And if you do, please let us know in the Zulip chat. Also, take a moment and write a few functions of your own, any function that does anything. And just see what you can get it to do and see what you can abstract away. All right, that's a short one for today. So I'm looking forward to talking to you more about this on Zulip, and to talking more about the Moonstone there later this afternoon as well.